Okay, so I put Bella in the corner because she's been helping me out, keeping me company while I've been doing this. And this will be the last video for today, thank goodness. So all we need to do is finish up 4 more examples that conclude 3.4.1. So again, as always, feel free if you want to, you can just try these out on your own and then look over the answers, or you can work them along with me and I'll tell you to pause. You know how that works. Exercise 3.4.1. Does more education result in more crime? So education was measured as a percentage of residents aged at least 25 in the county who had at least a high school degree. So we're just looking at proportion of people with a high school degree. Crime rate was measured as the number of crimes in Florida County in the past year per 1,000 residents. The correlation coefficient between these variables is 0.7 or 67. So it doesn't ask us to do this, but let's just think about what the heck that means for a moment. That would mean that there is a moderate positive linear relationship between education level and crime rate. And a positive relationship would mean as education goes up, crime rate goes up. Just throwing it out there. It doesn't ask us about this though. Instead, the first question we see is what is the coefficient of determination? So this particular example is really all about, I'm going to turn her off so I can set this down. This particular question is really all about what is what here. What do these words mean? Correlation coefficient, as a reminder, is our little r. This is also given as a decimal, which is a big hint that it's not that r squared, because that should be given as a percent. And coefficient of determination, well, this is the r squared, the thing that I want to be given as a percent. And the only thing we even have to work with here is our little r. And we know r squared is just that little r squared turned into a percentage. So we're going to take our little r, we're going to square it, and then we're going to turn it into a percent by multiplying by 100%. So we can do that. That's 0.67 squared times 100%. Which gives us out 44.89%. Okay? So we're done with that one. The next question says to describe the strength of the predictive power based on the guidelines above. Now again, I don't care so much about these particular guidelines. I just more want us to think about, is this good? It's right around 50%. This would say that if we wanted to predict crime rate using education level or vice versa, this particular model would have a fair predictive power. I hate when I do that. I don't know what it is in Drawboard that's like, once you press this with your hand, make it gigantic. Okay, so the model, linear model, would have fair predictive power. And I don't even know what it says in the little table because I refuse to scroll back up, but I think it's fair. Okay, so the next question is much more of a test question to me. So this is one where I'm going to say, take a moment, pause, try this on your own, and then we'll come back and work on it together. All right, so our first example, our first thing here, we see that we're looking at, we have an actual line given, we've been given the r squared, it is written out as r squared, which is fine, and we are looking at, it appears, sales, quarterly sales in billions of dollars based on the unemployment rate. So how does the unemployment rate affect sales? And just glancing, we can also see, if we want to kind of dig more into this, we have a negative slope. So as the unemployment rate goes up, sales will go down. And that one actually makes sense. So I feel good about this line. Our first questions tells us unemployment rate was 6% and sales worth 2.8 billion. Calculate your residual. So we're back to stuff from 3.3. We know the unemployment rate is our x. I know you do not need to make this 0.06 because remember, it's already given as a percent. And your y, your actual sales, are 2.5 billion. And again, units are billions of dollars, so no need to add a bunch of zeros on the end of that. And we want to calculate the residual. So what is our E? Well, we know the formula for E, right? E is y minus y hat. It's definitely something I'd start throwing on that note card. Unfortunately, we only have y, we don't have y hat. Oops, which is why this is that two-step question where step one is going to be to figure out what the heck y hat is. And we find y hat by plugging x into our line. So 20.91 minus 2.994 times 6. Which is 2.946. And already, by the way, I'm going to look at the wrong answer choices here. D is 2.946. This is something I do a lot as a common or wrong answer choice. I give you an answer choice that is an interim step. So if you're somebody who gets excited, you're going to circle that. So always show work. If you had this written down and you got excited and circled D, I would at least know that I trapped you with my wrong answer choices and that you really understood what you were supposed to be doing. But this also gives us a pat on the back that we're going in the right direction. So I like these as wrong answers. And then we can go ahead and plug in our E, is what we're looking for. We know Y is 2.4 and our Y hat was 2.946. We're subtracting a bigger number, so we should get out a negative 446. Right off the bat, just looking at these wrong answers, I want to talk about some of them. We have a positive and negative version, so if you didn't pay close attention to which was Y versus Y hat, if you didn't label everything really well, you would have gotten the wrong answer here. A is the desperation I got here, but I didn't know what I was supposed to do, so what she did instead was, well, 2.5, and then, well, what can I subtract? 6? Oh, that's 3.5, that's an answer, which is completely and utterly wrong. And then none of the above I like to throw in there, just in case you do something completely off the wall bananas I didn't expect. So it's usually just there as a catch for anybody who screws up. Most of the time it's not the right answer. And our last question on this one, you guys calculate a correlation coefficient. So again, all about knowing what the heck that means. Correlation coefficient is just asking us to find R. Now this is a particularly, this one is a little more challenging than going the other direction. We have R squared, which we want to go ahead and square root. Two pieces here. I know it says R squared, and so people will write R squared and then they'll be like, well, I take the square root, and the square cancel. No, just type in whatever's here. We do need to make it a decimal first, so that's one important thing. If we don't, we're going to get out some number bigger than our plus or minus 1 range that we're allowed. And then the second piece is we need to decide plus or minus. I know I had a plus or minus in the previous example or in the definitions, but it's only one. It's either a positive or a negative. And we need to decide, do these two things have a positive relationship or a negative relationship? And the way you do that is simply by looking at the sign of your slope. Since our slope is negative, that means this must be negative, right? We know there's a negative relationship. So now we know what we need to type in our calculator. And it appears the correct answer is negative 0.9397. And you can see the wrong answers here, forgetting that you needed to do the negative for the negative slope, thinking that the square root and the square just cancel each other out, or that the correlation coefficient is R squared, and it's that easy. And then these would be squaring instead of square rooting. So all those wrong answers. As you go through those old exams, you'll see them again and again and sort of notice them, pay attention to them. This test is essentially a standardized test. It is stuff that I use again and again. Use it to your advantage. Okay, so again, I'm going to give you opportunity to try 3.4.3 on your own. So feel free to pause and then come back. All right, so if you're coming back, we were looking at time spent on a computer versus their GPA, and we were just given a residual plot. So these are not GPAs, these are how far off our guesses were. And we can see a lot of interesting things already on this residual plot that I'm going to talk to you before we even get to the question. First is, holy crap, there's somebody who spent more than 80 hours a week on a computer. That person is a huge outlier and likely influencing a lot of what's going on in this relationship, because we know correlation and linear regression do not do great when it comes to an outlier. Then we look and we see eventually this part we start talking about large residuals, And we do have two people who we did a very terrible job of predicting for as well. We have somebody who we were off 2 points and another person who we were off 2.5 for GPA. That's like, I could have guessed that your GPA was a 2.0 and done better than we did for this person right here. That's absolutely terrible. So let's look at our answer choices here. We have two large residuals that are under predictions. We have two large residuals that are over predictions. Seems like those two are opposites of each other, so one of them is probably the right answer. So let's just make sure that we feel that B and C should be knocked out. B says the predictive power is good because the residuals are large. So these residuals are large relative to what we are actually predicting, which is GPA, plus or minus a +1 down to a -2 That's terrible. That means our predictive power is bad. The predictive power is good because there is fanning. There is a little bit of fanning in this graph. We can kind of see we're doing, I guess, better maybe this way. But again, that would mean our predictive power is bad, not that it's good. Both of those things are things that we do not want to see. Those are both indications that something bad is going on. So we have to figure out if these two large residuals are under predictions or over predictions. So even if you didn't pause the video, hopefully you have an idea in your head of what you think it is, because you're probably wrong. The answer is that our two large residuals were over predictions. Students always want this to be under predictions when they can see the actual graph because these points are under the line, right? And I understand that. But think about what the heck your residual formula is, right? E is equal to y minus y hat. These two residuals are negative, right? So technically, we are saying that y minus y hat is less than 0, right? They are negative. If we add our y hat to both sides, we are saying that y is less than y hat, that our prediction was larger than our true value. The only way to get out a residual that's negative is if this net number is bigger, right? So we're subtracting the bigger number. So our prediction needs to be over. So these are over predictions. The other way to think about it is your actual predictions are the line itself. So the predictions are on the line, that's over. Because if you think about how this originally started, these are the two values, the two guys, and these are their actual y's, right? And these are their y hats on the actual line. So the predictions are over the actual values. So again, as soon as you make the mistake once, you won't make it again. That's why I tried to give you a chance to think about it. But negative is over predicting and positive is under predicting. We also talked about it in the triathlon example when we had that +11 and we had under predicted when the guy would finish. Our last exercise is important because it gets us used to reading output from a program, a statistical program. This particular output looks like it's from maybe a Stata or something like that. Nothing we'll be using, but it's all fairly similar. In most true stats programs, this is what your correlation or your regression output looks like. So you have your predictor. It'll either say constant or intercept here, depending on what type of program you're using, and age. So age is our X in this case, because age makes more sense to predict your price than the opposite way around. So you usually have whatever your X variables are. And then you have your coefficients. These are the most important thing. They tell you what your line is. These tell us that price is equal to 12,319.6 minus 924 times the thing that's right here, which is age. So that's how this works. The rest of this we don't truly understand yet, but by the end of the course, and this is why it's actually later in a lot of textbooks, is because later in the course we'll understand what a standard error is, what a t is, what a p-value is. And for right now, we don't truly understand all of this output, but we can understand a line and what we can do with it. So I just did step 1. Good thing I read my question. Oops. And if we wanted to interpret this slope, now I'll give you guys an opportunity to pause and try out these two things on your own, or the next 3 on your own. Welcome back. Our interpretation of slope is here, miraculously. Remember, we have our units on our X, and then our X. Those are the two pieces I actually changed here. We have our Y, which was price advertised. Since our slope was negative, we have decreases. And then we have our slope amount with some units. Usually we'd put them afterwards, but I didn't want to write out dollars when I could just put it in front. All right, and then your value of your correlation coefficient. In order to find that, we're just going to take the square root of our r squared, which was given up here. We do need to make sure that we enter it as a decimal and that our slope sign matches the sign on our correlation coefficient. So those are the two pieces where we can make a mistake. Once they're done, we have our correct answer. And then the last thing we need to be able to do is interpret our correlation coefficient. So our interpretation of the correlation coefficient. There are 4 parts to this interpretation. We want to talk about the strength. Since we're really close to -1, we have a very strong relationship. It is negative, and we need to make sure that this always has that word linear to say that that's sort of our, takeaway for our correlation. We can only talk about a linear relationship, and then our x and our y, so we have some context to what we're talking about. So that's it. We will do the last section in class on Tuesday, and then we'll be getting ready for the exam in a week.